Hello. Today we are going to prove sine squared theta plus cos squared theta equals 1. This is a trigonometric identity that you might have seen before. Well, you might not have seen how to prove it, which is going to be the object of this video. We are going to quite have a short video here because there's not too much to do after we prove it. The proof might be quite involved though, so make sure you concentrate. And one of the benefits to proving this, as I always say, is that once you prove it, you'll be able to use it a lot more easily. For the simple reason that you understand it. And with maths, the more you understand it, the better it is, the more you're able to answer questions, and answer questions beyond the standard set homework that your teacher might give you. So, without further ado, let us start. So we want to prove sine squared theta plus cos squared theta equals 1. First thing I'm going to do is draw a triangle. I'm perfectly allowed and entitled to draw a triangle. In fact, I'm going to draw a right angle triangle with hypotenuse length 1. Brilliant. Let's make this side theta. Theta can be anything. Now, I'm going to use the trigonometry rules that you learned at GCSE to figure out the length of the other side. So, we're going to know that this is sine theta, and this would be cos theta. You can use the mnemonic SOHCAHTOA to get those if you've forgotten, but hopefully you haven't, and that will be the size of the triangle. And so, we also have a theorem that we learned at GCSE, which is called Pythagoras. I've even got a video on it, which proves it. You might want to check that out. But for now, we're just going to use Pythagoras. So we know that Pythagoras says that a squared plus b squared equals c squared, where c squared is the long side, the hypotenuse of the triangle. So let's put that into practice. That means that cos squared theta, this side, plus sine squared theta, that side, equals 1, that side. Oh, what do we have here? We have the trigonometric identity that we wanted to prove. And thus we are done. Almost. Can you spot why we're not done here? Okay. The reason why we're not done is that this trigonometric identity, being an identity, is true for all values of theta, even negative values. Whereas here in this proof, we've used a triangle to try and get what theta is. A right angle triangle, in fact. The fact that it's a geometric shape means theta must be between 0, it must be greater than 0, and it must be less than 90 degrees because I have drawn a right angle triangle, and so I've only proven it for this instance. Well, that's kind of good enough. I've proven it for theta in between 0 and 90, but I haven't proven it for every theta. So, let's try and prove it for absolutely every single theta in existence. Well, let's just say you give me a theta that's greater than 90 degrees. I'm not going to prove it for when theta is less than 90 degrees. The same principle applies, and I'll let you do that at home. But if you give me a theta greater than 90 degrees, I want to show that this equals 1. Well, let's do it. That is going to equal sine... No, it's not. Sorry. It's going to equal cos squared 90 minus theta plus sine squared 90 minus theta. Why is that? Well, we have, don't forget, the two equations, cos theta equals sine 90 minus theta, and we also have that sine theta equals cos 90 minus theta. I'm going to prove these two afterwards at the end of the video, but for now let's just take this for granted. So I've got this, and I'm going to hope that this, and therefore this, 90 minus theta, is less than 90 degrees. If it is, then it equals 1 by the formula we proved at the start. If it doesn't, then tough luck. I'll just use these two equations again to get 90 minus theta, which is going to be what am I going to get? I'm going to get I don't know actually. 90 minus 90. Well, actually no, I'm going to end up getting what I started with. But what I can do is start taking more 90s away. So in fact, what I should have done here is, let's do it like this. Apologies. Theta minus 90. I'm going to change these formula quickly. It's exactly the same thing, and I'm going to have to prove it after. But I'm sure you won't mind. So, is this actually true? 90 minus theta. I think that is, and I think they work. Anyways, so that means that what we have here is cos theta here is actually minus sine theta minus 90. So that's it right here. I'm not going to put the minus sign because we have to square it, don't forget. And the square will cancel the minus sign out because negative 1 squared is 1. And here we have sine squared theta is cos squared theta minus 90. Well, we can see that here. So that works quite perfectly then. So, hopefully these are less than 90 degrees. And then we can use identity we've proven. If not, we can just do the same thing again and minus another 90. So we would have minus 180. So that should be now sine squared theta plus cos squared theta and minus another 90 to get theta minus 180. And as you can see, we can just keep going until eventually this is between 0 and 90. And when it is, well, we've got an identity to say it is equal to 1. And therefore, this must be equal to 1 because of the chain. That is equal to that, which is equal to that, which is equal to that eventually at some point. So the only thing we need to do is prove these two. Okay, so let me prove this first of all, that cos theta equals minus sine theta minus 90 degrees. Well, the way to prove it is, and we're going to try and prove it without the triangle, is when you see, it's not really a proof here I'm going to give you, I'm just going to show it to you on the graph of sine and cos. That should be at 0. Poorly formed graphs that I've done, but that's the problem, we're not having graph paper, I'm sure you'll forgive me. So the top one is sine and the bottom one is cos. and these axes are theta. Okay, so as you can see, for any cos theta, just say this bit, this one here, if we minus 90 degrees, so wait a minute, so this theta is going to, cos of this theta is going to be equal to 1, as we can see. What is minus sine theta minus 90? Well, first of all, theta minus 90 gets us to here. Sine of it is going to be this bit, which is minus 1. And then we take the minus of it, which is going to be 1. And we can see it quite easily. And the reason why this works is because cos is just a shift of sine, and sine is just a shift of cos. So actually, the formula is cos theta is sine minus 90 theta, sine 90 minus theta, because it's just a shift. But that is also equal to minus sine minus 90 minus theta, which is equal to this thing. Done that wrong there. It's equal to theta minus 90. And the reason why I had to get from there to there is you just see that this is the graph of sine, and where we have theta, negative theta is going to be the minus of what we've got. So that proves these two formulae. Well, it proves the top one, but you can prove the second one at home in the exact same way. Once you get these, you can then extend the identity that we proved for theta is less than 90 degrees but greater than 0. You can extend it for any theta, and you end up with this. I hope you've enjoyed this video. For more trigonometric identities, join me in the next video where I will prove a few more and I'll show you how to use it. For now, I hope you've enjoyed my video, and I'll see you next time. Goodbye.